All right, so hopefully everyone can see the slide deck so far. Basically, the format is going to be like 4 slides, and then I'm going to switch into my browser screen share, and I'll show some code and stuff like that. Our session right now is about using Hyper API in a Google Cloud function. So you've seen a couple examples today of Hyper API. There was a recording of it earlier. But basically, the Hyper API's goal is to create a Hyper file, and then you can do something with a Hyper file. You can load it into Tableau Desktop. You can publish it to Tableau Server. But we thought, why don't we just show an example of something maybe not as many people are doing, right? So, and actually, this whole use case came about from a project I was working on earlier this spring. We mentioned at the beginning of today there was like this Google Smart Chips integration, and we were trying to get like telemetry data from that. And, so we created this process of getting that telemetry data from GCP into Tableau Server, or Tableau Cloud, really, so that we could actually track some of this stuff. For anyone who missed the session earlier, my name is Takashi Binns. I'm a partner engineer for Tableau. I'm on the same team as Kevin. I've been at Tableau for almost 5 years, getting close. And yeah, for a while I was a sales engineer. So I dealt with a lot of different customers, looking at different use cases, primarily healthcare. And then I switched over to the tech partners team a little more than a year ago. So I've been kind of working with partners since then, basically helping any kind of integration you want to have with the Tableau API or developer stack. So it doesn't matter if you're using Hyper API or web data connectors or dashboard extensions or anything that ends with API or SDK. If you're a partner and you're building some integration, you're probably working with our team at least a little bit. So that's some background on me. I do have a forward-looking statement slide. I actually don't know if I need this, but it's kind of been my default behavior that if I'm presenting in front of anyone, I need to have a forward-looking statement slide. Yeah,
you do. In fact, you do. Yeah. No one else did except you or me. You.
Well, yeah. So anyway, the point of this slide is a lot of text, but really all you need to take away is that some of the things you see, I'll make a mention of it if it is, but anything that's, a future release or it's a new feature coming out down the road, please do not make any purchasing decisions based off of that. Make your decisions based off of features and functions that are available currently today. Great. So now that we can move on, I want to start with, before we get into like the solution and how it works and everything like that, I wanted to talk quickly about how data normally gets into Tableau. So that'll help you understand some context of why we did this and why it could be useful to somebody. So when we're talking about, getting data into Tableau, the typical workflow is you open up Tableau Desktop. It's going to prompt you, hey, where do I find my data? And you're going to pick from a named connector, whether it's Redshift or BigQuery or Snowflake or a CSV file, Excel file, wherever it comes from. You pick your connector. You probably have to do some kind of authentication, to prove that you actually are allowed to talk to that data source. And then you'll see a list of tables. You can drag them in, create your data model, and then create your analytics on top of that. Now, when you're going through this, you're either going to create it as a live connection. So if you're working with something like Snowflake, that's really fast. Like, yeah, live connection sounds great. Sometimes you might be working with a really slow technology, or if it's a flat file, like you can't run SQL queries against a CSV file. So in that case, Tableau would create a hyper extract for you. So hyper extracts, if you're super new to them, they're basically like data files. So it's a way to take the data from where it used to be. It moves over and gets formatted in a Tableau structure called a hyper file. It's a high performance columnar database, so it's very, very fast. It scales really well. And it's just a way of taking the data from one place and making it easier and faster for Tableau to work with. A lot of times we see customers using hyper extracts if your database is slow. So even if you have like a modern database like a SQL Server or even Snowflake, you really have to be aware of like the load that server is able to handle, right? So even though you might be running a simple query, there might be 1,000 other people running, similar or more complicated queries at the same time. So just because you have a database that you can connect to and you run queries against, doesn't necessarily mean it's going to be fast when you're connecting from a BI tool like a Tableau. And on top of that, a lot of the queries that BI tools generate are grouping queries, right? So if you're a relational database, you probably are built to handle either transactional things like insert this one record, or select these 10 records or all the records from today. You are not really built to handle aggregations, right? So you can do them, but it's not optimized in that format. So a lot of times if you're writing creating a dashboard, you're creating groupings like show me all the products grouped by category and filtered on this date, and then also group it by year because I want to show a line chart. Those type of queries are definitely heavier and cost more from a performance perspective from database companies. So by converting it to a hyper extract, it's built for that, and they end up being a lot faster in a lot of cases. So either way, you're connecting to the data. Tableau will generate some SQL, and we'll send that SQL somewhere. Either it'll be a live query, which means that SQL goes all the way back to the back end, like SQL Server, Oracle, whatever you're using, or you're executing it against the hyper extract itself, which is presumably it's local, right? It's living on the Tableau server or Tableau cloud environment. There are pros and cons to each, right? Like, does your data need to be really fresh, or is it okay if it's recycled every hour or so? Those are questions that are going to depend on the use case. But a third option is to actually push data to Tableau. So in the last example, like the normal flow, we're always pulling, right? Tableau will ask a query and pull the results back in. In this example, we're going to push the data from somewhere to Tableau. So it's actually not as hard as it sounds. You just have to create a hyper file using the Hyper API, and then you need to publish that hyper file to your Tableau cloud or Tableau server, and you can do that using our REST API. So that's a little bit of background. Let's go to the next slide here. So I kind of explained like what the normal process is, what this process is going to be like why do we even do this in the first place? Like, what's the point? And there's really two main reasons. So first reason could be that maybe Tableau doesn't have a native connector for it, right? I mentioned the normal workflow. You open up Tableau, you say, oh, my data's in Snowflake or it's in BigQuery. Well, what if your data doesn't live in one of those named connections? We have a lot of them. I think it's 120 or something like that you can pick from. But you can, maybe you have data somewhere else. So actually in our Smart Chips integration, our event log capturing all the telemetry was stored in Google Firestore. Because Google Firestore it's a serverless infrastructure. It's very cost effective, in terms of scale. And it just basically collects JSON objects, right? Or documents, really. So it could be any data structure you pass in is fine. The downside is that there are no native ODBC or JDBC drivers. So even selecting that generic ODBC, generic JDBC, that wouldn't work, if you're connecting to data in Firestore. They do have APIs or SDKs really, but they're in Python, Node.js, Java, things like that. So in our case, it'd be really great if we had a way to take the data from Firestore and just push it to Tableau. Then I don't have to worry about having a named connector. The other use case for this would be if you have data that needs to be refreshed on a schedule, but not necessarily the schedule in Tableau. So I'll talk to customers sometimes where they'll have an ETL job and it's got to do a bunch of things, right? It's got to go take the data from here, trigger this thing over here, and then write all that data to some database over here, and then finally it's done. Well, really, you'd like to be able to trigger the data to get set to Tableau as well as the last step in that process. And some people do this using, REST API calls to manually, to explicitly trigger our schedule jobs to run. But it's a little weird that way, right? Like you create the schedule and then immediately tell it to run. So an alternative here is to say, hey, why don't we just create, the data as a hyperfile and then just push it straight to Tableau. You can do it on whatever schedule you like. You also, because we are doing this in a cloud function, you can also have it be event driven, right? So it's really, when you create a cloud function, you typically use it as a HTTP trigger, which means it's just an endpoint, a REST API call that you can make. And you can trigger it from a REST API call. You can trigger it from something called Cloud Schedule, which is just a cron job scheduler in the cloud. Or it can be triggered from an application or a different event. Anything that you allow can hit that endpoint and trigger this job to run. And as a reference implementation that we're going to see today, we used a cloud function. Here, actually, let me just show the architecture slide. We basically have on the left side is GCP. The right side is either Tableau Cloud or Tableau Server. This could work on either one. Doesn't take a lot of things, right? You've got data in Firestore. And I picked Firestore because that was my use case, but maybe you want to pick data from somewhere else. Maybe you've got, log files, or maybe you have log data from other things that are running in GCP. Maybe you've got, some other things that you need to, read these JSON files or read these Parquet files and do something with, and then you want to send it to Tableau. There's a whole bunch of different use cases where the data can come from. But the point is you have some compute, which in our case is a cloud function that will query the underlying data source that we want to grab data from. We'll use the Hyper API to actually create the Hyper file itself. And then we'll use the REST API, the Tableau's REST API, to push that Hyper file over to your Tableau Cloud or Tableau Server environment. And in our case, I set up Cloud Schedules, which is a Google managed service for cron jobs, to be the triggering event. So I'm not triggering this from an application or something like this. I'm just saying, hey, once a day or whatever I want to set it as, I can go and have my cloud function execute. And it's going to put it in a project on Tableau Server. Now, there's probably a bunch of different ways you could do this, but the way I thought would be most helpful would be to create a project on the Tableau Server side or Tableau Cloud side, and then all my collections from Firestore that I want to collect data from, I'm just going to push them all as different published data sources in the same project. And then if I want to use those projects in a workbook, it's just a permissions, thing to define like how people can connect to them, and the users can, obviously view their workbooks and dashboards, which are pointing to my published data sources in that project. So pretty simple architecture. So I thought we'd move on to what you actually need to do this, right? That's kind of why we're all here, right? So this example, I use the Hyper API to create the Hyper file. So you need the Hyper API. I use the Tableau Server client. You've seen a couple people use that today as well. Again, it's a Python wrapper for Tableau's REST APIs. So basically, any REST API call that you see on our website has probably got an equivalent Tableau Server client call. Before I started using it, I was thinking to myself, what's the point? I'll just make my REST API call using Axios like I always do. But there are a couple neat features that it does. For example, publishing to Hyperfile to Tableau Server or Tableau Cloud is actually two API calls, right? You have one API call to actually take the file itself and then upload it to Tableau Cloud. And then you have a second API call to say, hey, that file I uploaded, turn that into a published data source. Because your file, in this case, it's a Hyper extract, but a different user or use case might want to upload a workbook or something else as a file. So there's kind of like a two-step process, but the Tableau Server client wraps it all into one call. So it kind of simplifies your life a little bit there. So because I'm using Tableau Server client and the Hyper API, the common denominator there is Python. Hyper API requires Python 3.8 at least. I think in my example, I used 3.11, but anything over 3.8 should be fine. And this example uses GCP, so I have some Google Cloud modules included in my Python as well. You could do this all in Lambda in AWS as well. Obviously, you wouldn't use Google Cloud modules. You'd use some Bot03 modules instead. But either way, that's kind of up to you. And in terms of source code, I tried to keep it simple. There are 3 files. So we have a requirements.txt. This is Python specific. It's basically a way of listing out the dependencies for your project, right? So I need the Hyper API. I need Tableau Server client. I need some Google libraries. Maybe you need some other things. You can define exactly what things you need or what modules you need as well as the versions. And then when you upload your code to the Google Cloud function, it'll look for this requirements.txt file and then just automatically install those modules for you so you don't have to worry about it. And then I split out my code into a config file and a main file, which has my business logic. So if I look at the config file, nothing too crazy here. Basically, it's one variable called tables, and it's an array. And I've got basically 2 parts to it. There's a Tableau section, which basically just asks, what should I call this published data source on the Tableau side? And I happen to call it Cloud Function Data for today's sake. And on the Firestore side, I need a couple things. First, I need a collection. So like what collection? Collection is kind of equivalent to a table in Firestore. So like which collection do I get data from? I have a whole bunch of fields. You probably saw something like this earlier from the, oh, and I just realized the formatting looks all terrible for you guys. It must have been something with the upload, the deck. I promise it looks neater and cleaner if we send you the slides. But anyway, the fields is basically a way of saying like I need to provide a structure to my JSON objects because Firestore can store any JSON structure that you like. But that doesn't really jive with a relational data source or something that Tableau would normally consume. It's kind of like thinking about, if you had a table with 5 columns and then you tried to append new data, but now you provide 6 columns, what's going to happen? Your database is going to not be happy with that. So in this case, we're not going to parse the data and try to derive the data types. We're just going to explicitly say, here are my here are my fields and the data types for each of them. One little quirk that I did notice, you might notice in the type section, it says SQL type.text or SQL type.double. Those, first of all, they're coming from the Hyper API, and those are all functions. When I first started doing this, I thought those were like an enumerable list, like a list of different data types. But it turns out they are actually functions. So you do need to, put the little parentheses around them. So it actually executes the function and returns properly from the Hyper API. And then lastly, I include a timestamp field. So one thing I wanted to do here was not just create a data dump of all the records or documents in my Firestore collection and push the whole data set every time. It seems like it would get pretty big over time and not that efficient. So what we did instead was say, hey, why don't we just key in on a last updated field? And that way I can just query for only the records that are new and just send the new data to Tableau. So let's do a demo. I hope this works. I think it should work. Let's find out. I'm going to share my screen. Let's see if I can share the whole screen. Okay, cool. I think you guys can see my screen all right. So let's start. I've got a couple things open. So I've got my Google Cloud console. I've got a Tableau cloud environment here, and I've got Visual Studio. So here's the code I was looking at earlier. This hopefully looks a little bit cleaner than what you were seeing before, but it's basically saying like, hey, here's the configuration that I've got. And if you want, because I made it an array, if you wanted to have multiple collections that publish data and have like multiple published data sources, you just add them as a comma separated list, like this whole object block. And then in terms of like my main code here, I'm importing a couple modules and stuff like that. I'm grabbing some environment variables. And then I've got kind of a main function down here that does all the work. So first, make sure all our environment variables are there, authenticate through TSC. We just saw this like not that long ago, so I'm not going to go spend too much time on it. But the main thing is we're going to go and actually check for stuff, right? So step 1 is authenticate to Tableau. Step 2 is to go check and see if this data source already exists. So in my config file, I say, hey, my data source is named Cloud Function Data. So when I go to execute this, I should go and check and say, hey, do I already have a data source called Cloud Function Data? And if I do, when was the last updated date? So now I can go and query for data from Firestore and say like, hey, I'm going to go, go get this collection. And then I pass in my last updated date here. So that'll add a where condition into the function, into the query. It's based off of the last time that data source is updated. So if it's a brand new data source, it's going to use a default last updated date. I think I made this like, January 1st, 2020. But otherwise, it's going to use the published date, the last updated date of the existing data source. And so that'll only return records that are new. And so once I have that data that's either new or if it's a brand new data source, it'll all be new, then I can go and move on to step 4, right? So step 4 is saying create a hyperfile. So I can take that data and I've got to create hyperfile function here that'll create the file locally within the cloud function. And then step 5 is to publish that hyperfile up to Tableau Cloud. Now the exception is, what if I don't have any new records since the last time I checked? That could happen. In that case, I just kind of return, right? I make a note in the logs, no new data found, don't bother pushing, and I kind of return from there. But let's dig into this a little bit. So get data source. This should look pretty similar to what we were seeing before. Sign into the server. I add some options here to search for it, and if I can find it, return an existing data source. The get data call, this is going to my Firestore collection. You can see I've got a little bit of a conditional thing here. I was doing some dev work locally, which I was using a service account for, but if you're running in GCP, you don't have to do any authentication with the service account credentials. Like, it's just going to run under the context of the service account that the cloud function is running under, right? So you don't have to add in your credentials or anything like that. You can see my query here. Like, go run a query against this collection here, and I'm going to add this where condition, timestamp field greater than my date filter, and then basically return this as a large data frame, essentially. Creating the hyperfile, you saw something like this a little earlier. One quick note, when you're running this in Cloud Functions, Lambda will be the same way. The only writable place on disk is in the temp directory. So it's literally -tmp. That's the only place you can write to on disk. I should also note that you do not have infinite storage in your Cloud Function, right? So I think in GCP, your Cloud Function storage is based on the RAM you assign to it. So I think I did 0.5 gig for my example, but you could bump that up if your data set is even bigger. Just know that you can't do enormous hyperfiles in here, because then you'd have to actually mount like a full-on file system. Lambda lets you do that. GCP does not let you do that. But again, the whole point of this is not to create 10 gigabyte hyperfiles. The point is to grab only the data points that are new, and then create a hyperfile out of that subset, and then push only that subset to Tableau. And you can see kind of what's happening here. We've got, we first create like a schema for a hyperfile, and then we go through and we add a table definition here with the list of columns. Each column actually comes from the config file. So I just grab the data type and the name. It's kind of already defined here, so I don't have to do too much work on this side. And then I run this command to actually create the table. That'll create the metadata, so the schema essentially of the hypertable. And then I loop through my data, and I go and append each row in there. And then the last one in here is this like executor. So you run this command here a whole bunch of times to add row after row after row, and then you run this executor command to go and actually do it. And the last step here, publish hyper here. Again, we're using TSC, so it's going to check, hey, if you've got an existing data source, we just need to append new data. So I'm actually running an API call to update my hyperdata. So here you can see the action I'm taking. It's an upsert. So I can basically say, hey, we're going to look for the table that we're uploading here. It's going to have the same schema and table name in the existing data source, and we can just match on a key field. So in our case, because this is Firestore, every Firestore has something called a document ID. So I know I'll always have a document ID in there, and it'll be unique. So that means I can handle records that are brand new, as well as records that existed before but were updated, as long as there's the last updated column in there or attribute in my Firestore collection. And it'll execute this command to actually send the data and update the data source, and hopefully that'll complete successfully. If I don't have a published data source, it'll go over here and it'll use this like overwrite. I could also have used create new, but I felt this was safer. And basically it'll go through and I'll create a new data source, and then I'll publish the hyperfile to that data source. So logic-wise, pretty simple. It's only like 4 or 5 steps in order to get this work. But let's see it actually go in action. Now I've got a GCP environment ready to go. but nothing's actually deployed here yet. So let's actually do that. I'm going to go in here and I wrote some Terraform because I'm very lazy. All I need to do is supply some environment variables. So project ID, that's going to come from GCP. Like, what's the ID of my project? Let's see if I can successfully copy and paste. I need a cloud bucket. So when you're using Terraform or some other infrastructure tool to upload your, create a new cloud function, you also need to upload your code, right? So you upload your code first to in Amazon, it would be S3 bucket. In GCP, it's called cloud storage, but it's still a bucket. So where are we going to put it? And then I need some Tableau details here. So if I'm going to switch back to Tableau Cloud, I can grab the site name from the URL, copy, paste. I need a project to put this in. So I'm going to I have this empty project here, GW test. Great. And then I need some credentials. If you've never worked with the API before and created personal access tokens, it's super easy. You just go into the little Tableau icon for your name under My Account Settings, scroll all the way down, and you should see a section here for personal access tokens. Again, I'm going to revoke this after the call, but for now, I can just call this DataDev, create token, copy the secret. So now I can paste in the value, DataDev. Great. I use these TFR files just because I push this code to GitHub generally, and I don't want to include all these values in the GitHub repo. So just a little trick that I use. But anyway, now I've already run a Terraform init because I was playing around with this to make sure it would work. So I'll just do a Terraform apply and see if I can get this right. DataDev.tfvars. Oops. It should be a dot, not a comma. See if I remember the syntax. Great. I can make this window a little bit bigger. So it's saying, hey, you've got 15 things that you've defined to do in Terraform. I'm not going to go through all of them because it's honestly a little bit boring. But the main things to keep in mind is we're first starting with this null resource. So if I check out the actual Terraform code, almost one of the first things that it's going to do is zip up my source code. So that config file, the main Python file, the requirements.txt, it's going to basically take that, it's going to create a zip file, and it's going to just move it locally into here. So I like to use this as a way to actually execute code through Terraform. When Terraform is really meant for standing up infrastructure, creating resources in a cloud environment, not for executing code. So the null resource is a way to basically get around that. So if I go back to terminal here, first it zips up all the code for my cloud function. Then it goes to make sure a bunch of APIs are enabled in GCP. And then you can see it creates some service accounts that this cloud function is going to run under. And it creates the cloud function itself as well. You can see it's creating the cloud function right now. And then the last thing it's going to do is create the cloud schedule. So the cloud schedule I mentioned before, that is just a way to trigger my cloud function based on a cron job. So I've got as one of my environment variables, I've got a cron, what do you call it? I guess it's a cron expression, which defines how often to run. So I have in mind running, I think it's 1 a.m. every day, but you can obviously change it to whatever schedule you'd like. And Google Cloud Functions do take a minute, maybe 2 minutes to actually create. Oh, there it goes. Cool. So just something to keep in mind. Just because you write some Terraform doesn't mean it all happens super quick. Sometimes it can take a minute or two. And the output here looks like that went well. Created 15 different things. And the output says, hey, I've got a new function called Firestore to Tableau, and that's going to run at basically 1 a.m. every day. So let's check it out and see if that worked. So let me go back to here. So far, my Tableau Cloud project is empty, right? I got nothing in here yet. if I go back to GCP, I should be able to look under Cloud Functions, and I've got this brand new function right here, Firestore to Tableau. And if I go in here, I can see the details of this. It was created just now. Yeah, I did half a gig of memory, but that's a setting. Add more or add less. It's running under this service account, which I made sure to give it the proper roles, so it's allowed to actually invoke Cloud Functions. I can see my source code up here, my config file, my main file. That should all be, the same thing I was showing you in VS Code. My environment variables that I specified in my TFRs file, that should be up here as well. Cool. Trigger. So having a Cloud Function by itself doesn't actually do anything for you. You have to actually run it. So it's basically a matter of hitting this API endpoint. And you can play with this too. I have it set up to run under HTTP. If I want, you can also make it required to run under HTTPS. You can also fence this in so that external applications can't execute it or can't hit it, but it's up to you. So let's actually run this and make sure it works. So they have a nice little testing option here. I can just click the button and that should go, oh, I never showed you my Firestore database. So let's take a quick look. I'm just gonna log into Firestore. And you can see I've got a bunch of documents here. So this is what I meant when I was talking about collections earlier. You can have multiple collections in here. I've got one called Cloud Function Data. Each of these is a document. This long little identifier here, that's the document ID. And then each document can have, lots of different attributes here. So I've got, this is product data that I mocked up somewhere. But I do have a last updated field here, right? So that's what I'm going to key in off of in order to make my queries. So let's see how this works. You can see this ran. It says, great, new data found, published to Tableau Cloud as Cloud Function Data. So that's the name of the published data source. And this ran in 7 seconds. Cool. Let's just double check. If I come back here to my Tableau Cloud environment, I should be able to refresh. And great, I've got a new published data source in here. I can see it was just created. And if I want, I can go and create a workbook in my Firestore here. You can't, it doesn't actually show you how many, but if I go look at the logs, I can say, hey, we found 0 data sources with this name. So that means there's no existing data source. We're going to run a query for all documents. And you can see the last updated date is greater than that default date I had set. Data fetch completed, found 31 new documents. So it created a hyperfile. And if it loads the rest of these, say, okay, publishing to data cloud, or publishing to the Cloud Function data source to this folder. It gets a new ID here. Everything looks done. Everything is happy. So that means I should have a published data source with 31 records in it because that's how many documents I had. So let's double check. 31. Awesome. So everything's working the way I thought. Let's do some testing though. So I mentioned I really want to create the new published data source if it doesn't exist. But if it does exist, I want to send it only the records that have changed. So what happens if I go in here and say change one of these documents? So I'm going to change this, instead of being black tea, let's call this green tea. And I also have to change the last updated date because that will be changed as well if I'm kind of under that assumption. And let's just put this for, I don't know, July 15th. Doesn't really matter. This is kind of a fake use case anyway. But now I should be able to run this again. And it should find only that updated data point and send only that updated data point to Tableau. So let's see if that works. Okay, I see right here, new data was found and it pushed it to Tableau Cloud. Great. Let's check out the logs and make sure it's doing what I hope it's going to be doing. Great. So I can see here, found one new data source, or found one data source with that name in this project. So you can see my last updated query here is a little bit different, right? It's based off of today's date, and it's based off of when this published data source was updated. And I can see my data fetch returned only one new document, which is exactly what I was looking for. So it created a hyperfile, and then appended new data and it's matching on the document ID. So if I go back to my data source here, let's go, and Tableau does some caching. So if I just go refresh the workbook right now, it'll still show the same records. But if I create a different type of object, like a flow, this is a way to like verify that that did just work. So let's create a new prep flow here just to test it out. And I can see my published data source here. And if I look at the actual data here, in terms of the data preview, it should say I still have 31 records, because and that's correct, because remember, I didn't add a new document, I just updated an existing one, so I still have 31. But if I look under my brand, now I can see I don't have black tea anymore. That's gone, and now instead it's replaced with green tea. So the point is, we've created a cloud function that will query a data source that Tableau can't connect to, and it'll either create a new published data source on Tableau and send all the data, or if it finds that data source already exists, it'll grab only the data that's new and upsert it into that existing published data source. And the last thing I didn't show was the cloud schedule itself. So I don't have a shortcut for that. Let's do cloud scheduler. You can see I've got one here, Firestore to Tableau. It hasn't been run yet, but basically all it's going to do, and you can see it's pointing to my HTTP endpoint here, and it's looking like 1 a.m. is the next run. Yeah, 1 a.m. tomorrow is going to be the next time it runs. You can try this out, like if you want, like if you just want to click on it. Where's the button for it? I think there's a button right over here, force run. Yeah, so you can tell it, hey, I want you to run now, even though the schedule, is for later, and it'll do that. So you can trigger that whenever you like. And if I go back to Cloud Functions, I can probably see in the log section here that it was updated and ran again. Somewhere in here. Sometimes the logs take a little bit to update, but yeah, that's what I wanted to show today. Thank you guys for tuning in. Let me just share one last thing here. We have some resources if you guys are curious about how to do this or do similar things. We kind of link to the same documentation that other people have about Hyper API and Tableau Server Client. I also included docs for Google Cloud Functions. And all the code that you just saw running, including the Terraform automation, is in the GitHub repo in the link there. We also created a tutorial that kind of outlines all the things I just mentioned. I think we're going to get that up on the developer site pretty soon. I don't know, maybe in a week or 2 weeks, something like that. And that's all I have for you. Thank you so much.
Thanks, Doc. That was great. We had a couple of questions about the Hyper API, really good ones, detailed. One of them was about, is there an option to do delete, insert, and is there standard options for incremental refresh? Yes, you can do delete, insert, update as an incremental refresh. There's on the documentation of the Hyper API, you can see all of the SQL commands that are supported by the Hyper API. There was also a really good one that I didn't know the answer to, but had to do some quick research. The Hyper API does support calculated clauses, which are interesting, and it puts it in a separate file called .hypercalc. Pretty neat. Learn something new every day. All right, so we are at 12:50. We have, don't know how many of you went to TC or tune into YouTube, but we are going to, Christian asked the question, are there any updates on partitioning, Hyper for partitioning? Good question. I don't know the answer. I'll have to find out for you, Christian. Unless Talk knows, which I don't know.
That I'm not sure about.
Yeah. We have to find out on that one.